Hi there, and welcome back. What we're going to do is solve a 3x3 system by using Gaussian elimination. And as you can see, I already wrote the augmented matrix below the system. And a reminder of our goal. Remember that our goal is to have ones along the main diagonal, zeros below the ones, and that enables us to use back substitution when we rewrite the augmented matrix into a system of equations. So let's see what happens with this one. So looking at this, I see that the first entry in the first row is already a 1, so that is a win. We don't have to worry about dividing by a row or interchanging rows. So now we're going to work on changing these to zeros. So that means we're going to take -2 row 1, add it to row 2 to make the new row 2. So I'm going to make a placeholder for that here. And we're also going to take -4r1, add to row 3 to make a new row 3. Okay, so let's see what happens here. So -2 row 1 is -2, -2, -2, followed by the augment, and then -10. Row 2 is 2, -1, 1, -1. So that gives us 0, -3, -1, -11. Okay. Now we move to changing row 3. So -4 row 1 is -4, -4, -4, and -20. Row 3 is 4, 1, 3, 9. And it looks like we have 0, -3, -1, -11. That's very curious. We ended up with the same row twice. Okay, so let's see what happens from there. So the new row, well, not the new row 1, the original row 1 is 1, 1, 1, 5. The new row 2 is 0, -3, -1, -11. And so nice, we're going to write it twice. The new row 3 is the same thing. Okay, well, we'll just keep following what we know to do here, and that is make a 1 here. Now, the only way I can really do that is multiplying row 2 by -1/3. So, new matrix, 1, 1, 1, 5, 0, 1, 1/3, 11/3, 0, -3, -1, -11. You might be able to predict what's going to happen in the next step. Okay, so now row 1 is pretty much done to us. We don't need to worry about row 1 anymore. We use row 2 to rewrite row 3, so it looks like we're going to take 3 row 2 and add it to row 3 to make a new row 3. Okay, so 3r2 is 0. I feel like deja vu because we're going to get the same numbers again, but mostly 0, 3, 1, augment 11. And then row 3 is 0, -3, -1, -11. Well, that's interesting. The new row 3 is a bunch of zeros. Zeros on both sides. So remember that that is a red flag for infinite solutions. When you have all zeros in one row, including on the right-hand side, that corresponds to a 0 equals 0 situation. So let's just write out the rest of this. So you have 0, 1, 1/3, 11/3 in row 2, and that was 1, 1, 1, 5. Okay, so there's our matrix, and we can't really go any further. We can't get the 1 where we need it to, which means there's not just one solution, or there could be 0 solutions or infinite. Since the last equation translates to 0 equals 0, that's true regardless, so that means we're in an infinite solution situation here. So we have y plus 1/3 z equals 11/3, and x plus y plus z equals 5. Okay, so that means that we can easily write all the variables in terms of z. So this second equation tells me that y is equal to 11/3 z, not 11/3 z, 11/3 minus 1/3 z. And that means in the first equation, I have x plus 11/3 minus 1/3 z plus z equals 5. And I got a little bit unorganized here, so I was going to draw an arrow here. So this means x, well, let's combine the like terms, plus 11/3 minus 1/3 z plus 3/3 z is plus 2/3 z equals 5. And then to solve for x, we just move everything to the other side. 5 minus 11/3 is 15/3 minus 11/3, so that's 4/3 minus 2/3 z. So I'm going to write this out actually. So we have our x equals, we have our y equals. So our solutions all have a certain form. X is equal to 4/3 minus 2/3 z. Y is 11/3 minus 1/3 z. And this is all for a given value of z. So that means when z equals 0, there's a solution. When z equals 1, there's a solution. When z equals 2, there's a solution. There's infinite solutions. It's hard to describe geometrically, but basically if you think about it, each of the equations are basically what's called a plane, which is a piece of paper. So if you imagine 3 pieces of paper in space that could intersect at angles and whatnot, and it just so happens that there's a line of solutions in space in 3 dimensions. So that's a little bit beyond the scope of this course, so we're just going to take it for granted because we know what happens with 2 variables. So there's our solution, all in terms of z.